Hi there, welcome to the Visual ModFlow Flex video training series. My name is Braden McNeil and I'm the lead software trainer here at Waterloo Hydrogeologic. In this video I'll discuss the 8th and final step in the conceptual modeling workflow using Visual ModFlow Flex. Once all of your conceptual model elements have been defined and one or more grids or finite element meshes are available, you'll be able to convert your conceptual model to a traditional numerical model. This process entails merging your conceptual model with one or more grids that were defined in the previous workflow steps. During the translation, Visual ModFlow Flex will automatically populate the specified grid or mesh with the defined geologic formations, boundary conditions, and property zone attributes, and creates the necessary input files for loading into your desired simulator. Separate workflows will be generated every time a conceptual model is converted into a numerical model. Structured finite difference grids, which work with the following engines: ModFlow 2000, 2005, NWT, LGR, SURFACT, CWAT, MT3DMS, and RT3D. These structured finite difference grids are converted to the numerical modeling workflow, which was covered in a series of videos, earlier videos, while unstructured finite control volume grids are converted to the unstructured grid or ModFlow USG workflow. In each workflow, you'll be able to view and edit the properties and boundaries on the numerical grid, then translate your model files and run the groundwater modeling engine, and finally view your results. For finite element models, Visual ModFlow Flex will generate the .fem problem file for loading into FeeFlow. Since a separate license of FeeFlow is required to run these finite element models, we'll not be covering this process in this video. So once you have the conceptual model designed in at least one numerical grid, you're ready to populate the grid with conceptual data. Proceed to the Convert to ModFlow Model workflow step in the conceptual modeling workflow as shown here. If you have multiple finite difference grids available, you can select from the available grids using the drop-down menu just above the Convert to Numerical Model button. When you're ready to convert the conceptual to a numerical model, simply click this button, and Visual ModFlow Flex will immediately begin translating the conceptual model elements into the numerical model structure. You'll also notice a window with a translation or conversion log will be displayed as shown here. The conversion could take several minutes depending on the size of the model and the type of grid that you used, as well as the complexity of the conceptual model inputs. When the conversion is finished, you should see a notification in this log indicating that the conversion has been finished, at which point you can simply close the window. So we can see here the conceptual model to numerical model conversion has completed. So we can close this window now. So in addition to that conversion log being displayed, a run node will also be added under the selected grid in the Model Explorer, as you can see here. This run node will be populated with all of the inputs from your conceptual model. There will be sections for properties, sections for boundary conditions, and any other inputs that may apply. A single grid may have multiple run nodes to facilitate simulating multiple model scenarios. Finally, after clicking on the conversion button, a new numerical modeling window will appear, as shown here, which includes all of the steps for the numerical modeling workflow. And that covers the conceptual to numerical model conversion, which is the final step in the conceptual modeling workflow. At this stage, you can proceed normally through the numerical modeling workflow, perhaps making changes to your boundary conditions or property values. There are some minor differences between the regular numerical modeling workflow and the numerical modeling workflow which follows on the conceptual modeling. The main difference is that after converting from conceptual to numerical models, you won't have the ability to edit or update your model grids. However, it will always be possible to return to your conceptual model in order to create new grids or edit existing grids and then reconvert that conceptual model to a brand new numerical model. At this point, I'd like to just quickly demonstrate the conversion of the conceptual model to a ModFlow USG model. So in that case, you would return to your conceptual modeling workflow and then select the Convert to ModFlow USG model node in the workflow navigator. Once again, you'll be able to select from available unstructured grids from the drop-down menu at the top, and then click the Convert to Numerical Model button. Once again, a run log or a conversion log will be displayed, and after a few moments we should see basically a new numerical modeling workflow open up for the ModFlow USG model. Once the conversion to the ModFlow USG model is complete, once again you'll see a run node added in to the Model Explorer under the appropriate grid, and you'll see a new workflow window open up with a shortened version of the workflow navigator. For ModFlow USG runs, you'll notice that you can only review properties and boundary conditions and define observations. Some of the optional steps from a regular finite difference grid, such as defining zone budget zones or particles, are not available or supported with ModFlow USG at this time. Thanks for watching. Stay tuned for more visual ModFlow Flex training videos. This is the final video in the conceptual modeling series. To learn more about the next steps, I recommend reviewing our video series about the numerical modeling workflow. For additional training resources, including user manuals and free tutorials, please visit the VModFlex support page on our website. A link is provided in the video description.